Hey everyone, welcome to the channel. This post is in continuation of the previous two posts where we first successfully created an account with DigitalOcean in the developer credit program. Secondly, we installed VRNET package and spun up a VMX Juniper Router Image. This video was initially about creating logical tunnels and then extending API access. I'll split this into two videos, keeping the video short for logical tunnels and separating API access video for the next iteration. Right? Let's say we have a single VMX router. How do we make this into multiple routers? So we use something called LT interfaces. LT stands for Logical Tunnel Interface. Right. So there are three absolutely important things that you have to remember when you're trying to create an LT interface. Imagine an LT interface is like a virtual interface or a virtual tunnel in a way like you have single router and you will use that single router to create multiple virtual interfaces, and then you'll connect multiple virtual routers or logical systems with these multiple interfaces. So the three most important things are A, encapsulation, that should be out of an Ethernet frame. B, there's something called peer unit. We'll see more when we are implementing this. Third, FPC in light mode is optional. I would recommend that you run it in the light mode so that the device itself will be more responsive. And then having tunnel services with a bandwidth of 1G or 10G. It's very, very, very important. If you don't enable tunnel services, you'll never see logical tunnel interface in the video, right? Sorry, on the system. Now let's see how to build two routers and expand the logic to multiple ones. So I have a VMX router. Let's consider a VMX router I wish to build two logical interfaces. Now these two routers connected by interfaces will be typically of the form LT00X A to B and LT00X B to A. I use this particular naming convention just to make it easier. So if, for example, LT0010.12 would represent the connection from router 1 to router 2, and in the same line LT0010-21 would represent the connection from 2 to 1. This is for easier troubleshooting, easier association when we are trying to build a topology or anything. It's not necessary, but this is something that I found extremely useful. We would have defined an encapsulation Ethernet on the unit, and each interface points to one another by the peer unit definition. So we'll have peer unit, and we'll say under the interface you'll configure the peer unit number and you'll refer the same peer unit number on the other end. This sounds confusing, but it is pretty a easy example. So you have that as logical system 1 and you have this defined as logical system 2, and these two are connected by our logical tunnels. We'll also hop into the DigitalOcean's terminal, and then we'll have a clear picture on how to configure it. You can expand this up to any number of logical systems. Technically you can go up to 14. Most of the L3 features are supported on logical systems. I hold two JNCIs, one in service provider and one in data center, and logical systems are always the go-to options. Even for proof of concept, I typically use logical systems. Lightweight and it's easily accessible. So I logged into the DigitalOcean. So we'll first inspect what is the IP address of the Docker container. So Docker PS would list out the current container which is running it, and the inspect command which will list out the IP address assigned to the container. The long version of this command is you just say docker inspect and the Docker name. It will give out the entire details of the Docker container, but we are as of now interested in the IP address. So the shorter form of the command is like really nice, as you can see here. Now the initial configuration of this particular Juniper Docker image is picked up from the Docker folder itself. So you can see it's the juniper.conf file. There's nothing much there. So we will see the root authentication, the password, and VRNET user and password. So VRNET lab is the user, and capital VR hyphen small letters NET LAB9 is the password. So unless like you have a chance to like replace this particular file with whatever file you want, and that will spin up the initial configuration. That would be the idea for automation as well, but as of now we'll stick to the basics. So we are into the router, right? So first thing, let's configure FPC in the light mode, right? And seeing if there are like LT interfaces on the system. So just to see, there are no LT interfaces on the system. So the first verification thing is like we need to make sure that there is an LT interface on the system. Configuring tunnel services with 1G, and after the commit you should now be able to see the LT interface appearing on the interface TERS command. So let's see. Yep, we see LT0010. The number can change, probably it can be a different number for you, but overall the concept remains the same. So let's configure the interfaces, unit 12 and unit 21. So as I've said, like we need three most important things. One is encapsulation, the other is peer unit, and for an interface, this is an L3 interface, so we'll have an IP address as well. So we'll set encapsulation Ethernet. There is like frame relay encapsulation and there are other sorts of encapsulations, but I'm sticking to Ethernet. You have family address, and that interface is configured. So if I show the interface, I see 1.1.12.1 is the assigned IP, and there is a peer unit 21. Now I'll go to unit 21 encapsulation Ethernet, and I say peer unit 12. So this unit 12 will actually represent to the sub interface unit 12, and that's how they are related. Now we have both the interfaces. We'll do a commit. So after the commit, we can see like two interfaces that are listed out there. Now configuring and associating these interfaces with the logical systems is the most simplest part. So you just set logical system ls1 and the interface, and set logical system ls2 and an interface, which is 0010.21 for ls2 in this case. So that's it. Like now if you like commit, you have technically created two different virtual systems with two virtual interface. Generally on a hardware you'd like probably hairpin it and use a physical interface. You don't even have to do it. It's a very handy feature on Juniper routers. I really like this. As I've said, like I've used extensively for my IE preparation, especially for SP. Let me see like if there is any global way of looking at the interfaces on the logical systems. Probably it's not there. So let's log into the logical system, right? So how you do that? So set CLI logical system ls1. This is a very interesting command. It took a lot of time for me to figure this out initially in my preparation days. So you can see that you are in the logical system, so it's main host name colon the logical system name. Trying to configure OSPF. As you can see, there is only one interface. You don't see any other interfaces from the global table onto this. You're like technically segregated everything. So I've just run OSPF. Now the way you go out of the logical system is like that hardware, where you exit and then log back into the router, but there is an easy way, I guess. So then we can use clear CLI logical system if I believe it correctly. So clear CLI logical system, yeah. So now it's like you are into the main table again. So we'll do the same thing for ls2, and let's go into the terminal and let's see the interfaces. Yeah, we can see a subunit 21. So set interfaces. No, it's set protocols. OSPF is associated in area 0 interface LT0010.21. Do a commit, and if everything is correct, we should be able to see OSPF neighbor relationship between these two. Yep, fantastic. So we have like successfully created OSPF between two logical routers. We'll now try to like associate a loopback interface, right? So we'll do loopback 0.1 and loopback 0.2. The only catch is like you have to assign loopbacks to the logical systems before you commit it, otherwise it's going to give an error. Yep, that's what I was saying. So set logical system LS1. That's because like Junos cannot have multiple loopback interfaces in the same table, so we'll separate it into the logical system. So let's try to include these two interfaces into the OSPF process. So now we can see like there is now new loopback. So set protocols OSPF area 0 interface LS0.1. And we'll do the same thing on LS2 as well. So this should like take the loopbacks and advertise them into the system. We should now be able to like ping across. We should be able to see an OSPF route. So run show route protocols OSPF. Yep, you can see the OSPF route of all ones on LS2 logical system. You can ping it with and without source, and it should be like clearly reachable. So this completes the logical tunnel concept. We will explore the DigitalOcean API and some PyEasy management options in the next video. Right. Thank you so much, and I'll see you in the next video.